Okay, so this is question 4 from the 2015 C2 Edexcel paper. It says this sketch is a design of a scraper blade. It says the blade consists of an isosceles triangle COD joined along equal sides of its sector OBC and ODA of a circle centre O and radius 8. Now we know that AOD and BOC are equal. So we know, looking at this information, that this sector here is equal to this sector here. Obviously I haven't drawn that perfectly, but hopefully you get the idea. Now we also know that DC here has a length of 7 centimeters. Now, given this, we know they're circles and sectors of radius 8. We know therefore that this line here is also 8 and this line here is also 8. Now, for the first part of the question, it says show that angle COD is 0.906 radians, correct to 3 significant figures. So, what we're trying to find here, if I just take out the isosceles triangle, here that length is 7, here we know that's 8, and that's 8, obviously all centimeters. And we're trying to find the angle COD. So we're trying to find this angle here. We're trying to find, let's just call that theta for the moment. So we're trying to find that angle there. So this is a triangle with 3 lengths that we know and 1 length that we don't know. And hopefully you can understand or realize that this has to use the cosine rule. Now, if you look at your formula book, you'll see that the cosine rule is a squared equals b squared plus c squared minus 2bc cos a. So that's if we're trying to find the length of a squared. In this case, it will be looking a squared, or a would be that length there. So let's just label that length as a just for the moment, because then that would be angle A. B and C, it doesn't really matter. You can tell that that's going to be 8 and 8 because, well, they're the same. Now, we're trying to find the angle. So actually, we can rearrange this equation. So we can write that as cos of A is the same as a squared minus b squared minus c squared all over minus 2bc. And if we find that information, if we just substitute in the information that we have, you can see therefore that cos of A will be equal to a squared, which is 7, so 7 squared minus 8 squared minus 8 squared all over minus 2 times by 8 times by 8. Then you're going to end up with a solution for cos A. Cos A should equal whatever you get there. And then finding the inverse cos of that, you should end up with angle A, or in this case COD, will be 0.906 radians. Obviously make sure that your calculator is in radians mode. I know some people, you want to rather work in degrees, but with a question like this, just put your calculator straight into radians mode and it should give you the answer straight away as 0.906 rad. Otherwise you'd have to find it in degrees and then convert it into radians, which is can be a bit tricky and can make you lose marks. Okay, so moving on to part B, we're trying to find the perimeter of the shape now, which means we're going to be adding this length here, AB, which we know is 16, plus DC, which again we've been given is 7, and adding these two arcs together, AD and CB. Now, looking at the information that we had beforehand, we were told that the angles AOD and BOC are equal, which must mean that these two sectors are the same, which means then we're just going to do 2 times by the arc of AD. Now, working out the arcs in radians, or working out arc length in radians, we're trying to find out the arc length. So arc length is simply worked out by theta r. Now, looking at the information we have beforehand, we know that the radius of each arc is going to be 8, and now we just need to work out theta. Now, an easy mistake to make here is just to assume that the theta is 0.906 because you were given it previously. However, that is that angle here. We know that that angle there is 0.906. And we're trying to find out this angle here. Now, it's on a straight line, which means it's 180 degrees. In radians, that means that it's going to be pi. We're now going to take away the 0.906 to give us what happens to be both of these angles together, or what's left. And because they're equal, we know that then we're going to divide it by 2. Which therefore means to work out the perimeter, which I'm just going to call P, is therefore going to be 16 plus 7 plus, and then in brackets if you like, 2 times by the radius, which is 8, times by, and then just typing in this into your calculator, pi take away 0.906 divided by 2, and that will give you your final answer of 40.9 to 3 significant figures. Okay, so for part C, we're now trying to find the area. Now, if you look at actually the information that we've been given, we know that we need to find out the area of a triangle here. Again, perfectly covered up. So that's the area of the triangle. And then add that to the area of these sectors. And as we told beforehand, these two sectors are the same. So actually, it's just the triangle plus twice of the sector. Now, working out the area of the triangle, we have the lengths that we need. We have the angle as well. So this will be using the formula of half AB sine C, and working out the area of a sector, it's going to be 2 lots of, in this case because we're trying to find 2 sectors, the formula being theta over 2 times by r squared. Now, that means that the triangle will work out to become half times by 8 times by 8 times by sine of 0.906, and we're going to add that to 2 times by 8 squared times by a half of, and then making sure your calculator is still in radians mode, the same angle that we worked out beforehand, and that will give you the answer of, well, I've run out of space here, so let's just throw it in here. The answer you should get to 3 significant figures is 96.7.